Hopefully you hear my voice. Show your hands if you hear me. Yeah, that's nice. Okay. So let's open this room with a nice presentation. Yeah, you can come. Yeah. Let's talk about the cloud a bit while people are having their seats in the back. So Cloud Run is part of Google Cloud, and it's a managed service, which means that you don't need a sysadmin to set up hardware, any, let's say, machinery or set up services, because it's just there for you, and it actually works great for developers as well. My comparison about cloud vendors is that AWS has this concept of sysadminish, Azure has the concept of corporate, Google Cloud has the developer concept. So you can use the tools on your command line to actually do stuff in their cloud as well, on Firebase, on Google Cloud, and different services as well. Good. So today we are here to talk about Cloud Run, the rise of serverless and containerization. We will see what is serverless. You probably know that because we are 8 years in the industry for serverless. We will see containerization just a bit, and we will see how we can actually make a container work as a serverless. And the nice things about this is that a container contains a full app, and that we can turn to cloud and so on. So on our agenda, we will see what is serverless, what are serverless pain points, how Cloud Run brings serverless to containers. We will see the build and run phase of it, mitigating cold starts, because if I ask you a pain point about serverless, the first one to ask is about the cold starts. I will show you some advanced examples, and we will see how to integrate Docker Slim on Cloud Run. My name is Marton Kodok. I'm actually Hungarian, but living and born in Romania. I'm a software developer working for a local company in Târgu Mureș, a city in Romania. I have a strong profile on Stack Overflow. You should answer questions like I do. You should gain reputation based on the questions, on the answers that you post. Also, you can post questions as well. There are these little karma points which can upvote a usable way. I'm appointed GDE based on my Stack Overflow activities since 2016, which is 6 years now. Time flies by. And all my articles and Twitter SlideShare are under Marton Kodok names, which you have it. You can use that information for later. Also, the slides will be uploaded on SlideShare about today's topic. And on Stack Overflow and GitHub, my stage name is actually Pentium 10. So it's a different way to connect me. Okay, so if we go back a bit in the history, once upon a time, we have AWS Lambda, Azure Functions, Google Cloud Functions. As you see, everything is a function. The serverless operational model for these were actually that no infrastructure, so you didn't need a sysadmin, you had managed security offered on the platform, but you had to do additional steps to ensure that your app is not reachable or it's an unwanted traffic. You pay only for usage, so it's a different model. You don't rent the server, you pay for the requests, the resources used. It's function-based, and essentially it's event-driven, so not kind of website or a backend for your project. It's actually event-driven. And it's a closed one, which means that you had to use the relevant version of the language that they provided, the languages and so on. So you had 5-6 options to actually work on it, and not the latest Node.js version, not the latest Python version, and so on. Cloud Run, a new product from the Google Cloud, brings serverless to containers. Let's see what have changed. So essentially, we need to assemble our code into containers, which means that we no longer have constraints because we can use any language, any library, any binary, which means that, let's say I'm doing a Node.js website and I want a PDF converter and I found it in Golang, which is a binary, you compile it, you can put in your project the binary and it works together, not as a different ways to do that. And you have an ecosystem of base images. So it's a nice way to actually work with containers of your use. What is serverless in the Cloud Run perspective? This is really easy and different. You need to shift your minds. Initially, there was in the history FTP uploading code, deploying them to VM machines, using different sections. Then we developed functions. Now we have containers and we containerize applications. We no longer have event-driven, we have app and service-driven concept, which means that there is an URL which is HTTP ready, it's ready on the internet, and it's a full app, or it's a full website, it's a full backend. It could be public, it could be behind an authentication. That's, in the background, it's a container, so that's actually the full project, no longer a function. And it's open, it's not closed, because you no longer need to use their languages, their version of code, because you create your own container. So last week, PHP just announced version 8.2. You are able to actually use it on Cloud Run in production immediately by assembling a container for that version. Or Node.js version is updated and Python now has this 3.9 version out, 3.11 I think, out, and they have that version as well ready. Okay, but whenever I have a discussion about serverless, people ask me, it's not good, it's slow, it has its own problems. Let's see what those are. Essentially, this is 2019 Serverless Days Milano. There was a queue run by Brett, and the top answers were cold start is a pain point. Then there is vendor lock-in. I mean, you can develop serverless in AWS style, you can develop serverless in Google style, you can Azure style. I will show you this because all this in Cloud Run is resolved. Then you have you don't have access to predictable billing, or you have problems organizing tracking functions, for example. You have all the functions separately, or you have one big function with parameters to access which part of it. Code organization is a problem, and so on. Let's talk a bit about Cloud Run pay-per-use. We have a container, we have a request to the container. The billing model is based on CPU memory and requests. That means that every option you need to pay it. And the billable time of how long is the request. If it's a website, it's fast. If it's something processing, it's a longer process. What this means? It means that we have overlap requests served by the same container. And this is a good feature. We have the instance starting, then we have a cold start until the first request is being actually routed to the service, because there is a bit of lag to get it going. Then the first request, the green one, is working, but meanwhile, if there is a second request coming in, it's served by the same instance of the container itself. And essentially, you pay one time the longest time period, not individually as two different time sections and so on. And this means that it's ready for concurrency. There is a pricing model. It looks ugly. No, I know. The important stuff is that 2 million requests per month are free. 1 million requests is $40. And compared to all this, what's in here, it means that if you want to use 1 gigabyte, 1 CPU, it's $3 for 2 million requests. So it's very decent, and it's very good for starting projects and medium-sized projects. We have clients projects where they don't have much traffic. They don't have 2 million traffic in a month, and they are fine with Cloud Run. We have clients where they have hundreds of millions of requests, and the bill is around $300. And it scales down when there is no traffic. It scales down up when there is a traffic. Good. Let's go deep dive, because was just the starting points of getting to know you, getting to know Cloud Run and the product as well. Essentially, we are a developer, so let's see how to code, build, and run of it. So, what it means to code? You use your entire Git repo, not just a function. For that, you need to package it to a Docker file or use the build packs technique. This is a second technique. I won't go deep into this. You can build image, or you can leverage Cloud Build. Cloud Build is a service in the Google that actually gets your code, creates a container, creates the image, and puts to where you set a destination. I mean, Cloud Run and different ways of that. That's called deploy, and then we can run and monitor. ChatGPT, it's the newest unicorn in the number of users in 5 days to 1 million. I actually used that yesterday to create this slide for you, how to create a Docker file. Because you just need to type here, you just need to type create a Python Docker file, or you can add create a Python website Docker file, and you will get a basic example of a Docker file. What we have here is the from section, the app directory on the container itself. This dot is the current directory in your project, which is moved to the app directory. You have the requirements file and then the command to it. Why we need Docker file? That's how Cloud Build and Cloud Run will actually know what app, what project to start in the Cloud Run for you. Essentially, there is a book about all these Cloud Run things. As I told you that I'm a GDE, there is Wiche Venema, also a GDE. He created a nice book about Cloud Run with nice drawings as well. So look out and tell to your managers, to your company that they should buy the book example, because you can use yourself and your colleagues as well. What's in the image itself? So essentially, from your code, it becomes a container image. The container image is stored somewhere. I would say to the novice people that it's not on Dropbox, it's not on a different system. It's called artifact registry, but you don't need to enable it. It will automatically enable in the background for you. It's just there, it's stored for it. For the container image, after that, the container image is being taken and published on the Cloud Run itself. There is a service, you name the service, like Devfest website or demo application, and then that image can be turned on many times. So it will serve traffic as it scales up. Good. I put here a screenshot of VS Code because I want to show you a lot on this, and it's better in a screenshot. Let's go slowly on this. So here is my project. It's a simple project. I have one single file to serve a web app. I simplified for use. It could be your entire project. Then you have a Docker file in order to describe the environment, Python, Node.js, what to start, and so on. Essentially, if you want to deploy it, you have multiple ways to deploy it. There is this gcloud utility, which you can install, and you should install it on your PC to interact with Google Cloud. The gcloud utility is a command line tool. You can run, for example, gcloud beta code dev, which means that in local environment, this folder, it will take live and you will have access to the URL to test it locally. You can deploy without using the Docker file. That's called build packs, and Cloud Run has natively implemented an X-ray scan of your folder, and it tries to detect what kind of language, what kind of project you are running, and it will automatically infer the container for you. But my favorite is to use Cloud Build. itself, because when I place my Docker file inside, I drive the version, I know what's in there, and I can just use gcloud build submit. All this is tasks JSON file in VS Code. You may use this technique to actually have a quick run pane. You have here a quick run pane. This is an extension quick run, and you can just, with the click, we can, for example, use cloud build submit, and the app will be up immediately for you in the cloud. What else we need to see eventually, that in the status bar, we see that this is the project that we run on Cloud Run. This is an extension of VS Code. I am the author of that extension. It's called GCP Project Switcher. You could actually use that in order to switch between different projects as well. I'm showcasing you because I created this for my own use. It's very helpful for me to actually see what project I am developing on. You should try it out. Now, once you have this, the code is uploaded, and essentially we need to see the specific files. So we have the Docker file and the cloud build. The cloud build YAML file is a step describe thing. We have here 3 steps: build a container image. Essentially, you need to use this site, like my site is the name of the image. You then push it like you set here, my site. And then there is the gcloud utility where you deploy the app. Run deploy my site, the image, which is the parameter. Region, you choose Europe Central in my example. Platform manage and allow unauthenticated. It means that it's accessible for the public, because natively when you deploy something, security by design is only internal for use. So you need to specify if you want to use in a public environment. Once you deploy it, you go to the interface, you get your application, demo 1, it's a green one. You get a random URL assigned to it. You can assign your custom domain. I don't detail that. You can have your custom domain to that domain, so the entire website. You have some charts, but I should actually use 2 charts here. Container startup latency. So the startup latency is around, let's say, 500, 600 milliseconds. This is the cold start, as you name it. And you have the memory. The memory is around 15%, which means that we used a model, we use the machine, or we use the YAML default values, so we eventually can scale down for it. For example, if you see 15%, you should scale down to use only, I don't know, 128 megabytes of RAM or 215. You can go up to 32 gigabytes of RAM. So it's really flexible for this. Okay, you may ask, what about cold starts? And let's speed up now, because these are the important types. If I have a discussion with you, the first one is that we should change the distro, or we can use something compact for the containers itself. This is just the basic stuff. You may have a 2 gigabyte container reduced to 200 and reduced to 60 megabytes. There are techniques to this operation. It's a bit sysadmin-ish. You may get help. It will spin off faster if the container is smaller and smaller. Cloud Run implemented a concept, Startup CPU Boost. Startup CPU Boost, actually, when it's enabled, lets you to assign multiple cores of CPU in the cold start phase, and only that time, in order to speed up the container boot itself. How do you enable it? You have a parameter CPU boost, and you add it to your command lines. Also in the interface as well, you have this available, and in other API system as well. I just use the command line in my slides, but it's available as well. Cloud Run introduced minimum instances. This is a really nice concept, because let's say you run a campaign, you know that you are going to send out, let's name it Cyber Monday, Black Friday, you are going to send out at 9 a.m. the emails. you can actually turn out minimum instances just before 9 a.m. to be ready. In the image, you have your code, you have your, let's say, the image itself, you have the main application, and there are idle instances waiting for traffic. And you can instruct this. It's a different billing model because you actually set the idle instances. The good news is that it costs somehow less to actually have an idle instance for that. On top of that, we have always on CPU concept. Always on CPU is actually a great way to keep the CPU running out of your requests. So you could do pre-caching or post-logging different operations, because in serverless way, once the request is hit, you process your stuff, you return the request to your user, the content, but after that you may have some additional job to actually do. Defer things after processing, logging, audit logs, post-processing, and so on. Always on CPU combined with minimum instances costs 10 times than the regular price. So you could keep these items. How this looks a bit... now on the interface, so you have startup CPU box as a option. You have minimum instances 0 to a number that you can use in order to have it ready, warm, and no longer you face cold starts. The CPU allocation could be different parameters, and you can use the CLI tool to actually set this. The billing model changed. If you look at here, this is the cold start, and this is your application. The requests could be spanned different ways. This is two overlapping distance requests. There is a gap here, and there is a secondary request here. Essentially, when CPU always allocated and you have the CPU is always available, and if you have this enabled, it costs you less on the red parts. On the red parts, because it's waiting for the traffic for itself as well. It's a great way to actually speed up application. But just a final word on the minimum container instances and CPU billing. I noticed that when you have the below activated, you are not charged for the request part. So it behaves as an instance for you. And it behaves and costs less than a VM. Why? Because when there is no request, it's only 10% of the price as well. So if you, for example, start a VM and you run for a full month, and if you do that on a Cloud Run with one single instance, with always on CPU, but when you don't have a request, is 10 parts of the price, you will get lower price in the end of the month for it. Auto-scaling, briefly, when there is no request, scales down to 0. So essentially, not scales down to 1, scales down to 0, which is a great feature to have it. You can have up to 1,000 container instances. If you increase the instance types, this is halfen. So if you use, for example, a 60 gigabyte 60 CPU system, the number initially to start the container instances is halfen, so 500 and so on, just to actually save you on problems we will see later. Essentially, you can do 1 million simultaneous requests without any additional work. But concurrency, but someone tried this and ended up with a 72,000 bill overnight. Yes, it's a problem, as you say. So he had unwanted traffic, or I don't recall his example, he did a while loop, and he actually added so much traffic to it that the container was scaling, concurrency let it, so it actually had overnight bid. This was fortunately an experiment. So it was intended, as far as I know, it was an experiment. So concurrency sometimes is not best. So you can have usually the same number of traffic also with using, let's say, one single instance no, sorry. Yeah, it's the scaling. Like you have a parameter, I didn't mention it. You have a parameter in the YAML file where you set the concurrency. And if you set 1, it means that each new request is hitting a new container. So it means that you pay a new CPU set, a new CPU set. But if you set the concurrency, for example, to 80, it means that less instances are actually booted for you. And that costs you less money because you pay less RAM, less CPU, and so on. So it's actually a good way for that. But I don't want to expand more on this topic because today you will have another session of Cloud Run about scaling, and you will have 20 minutes to actually hear about scaling only for that. So I will jump to my next part in order to have the second talk for you ready. Often in the cloud folks, we see that Cloud Run is called king of serverless compute. Why? Because it has so much additional stuff in it. Like you have traffic control, security benefits, health checks, session affinity, SLOs, service level objectives, and second generation environment with disk support. Briefly, because I want to actually finish on time, what means traffic controls? Well, in a function environment, serverless tools didn't provide canary deployments. So you could not deploy a version that didn't get traffic. In Cloud Run, you can deploy a version or a revision. Let's call it revision because that's better. You can say it that it has no traffic. Oh, why it jumped? You can say it has no traffic, but it's ready. You get a special URL for it. Why it's good for you? Because you can run your own tests. While the entire version, the main version is up, but you have a secondary version there as a, let's say, candidate one. And you can test that. Once the candidate one is passing the tests, you can gradually increase its rollout. You have parameters to actually gradually increase the rollout. So you can have like 10%, 90%, 20%, 80%, and you swap entirely 100% the new version. This is interesting and it's really helpful for you. How do you develop code and so on. Next thing, security. You can mount secret managers. Secrets from secret manager. So Google Cloud has this concept of secret manager. That's actually a product where you enlist your passwords, API keys, and someone from your team puts in there. He sees it, he puts it there. After that, he doesn't see it. But you are able to actually access from the container as a mount. It means that it's mounted like a virtual drive, like a / my mounts my secret to Twitter API. And when you read that file, it's virtual file, you get back the key. And that way you don't need to assemble in the code itself. It's externally mounted, which is very good because if your container is stolen, you don't get the API key in the code itself. It's mounted directly after it's booted. Binary authorization and customer managed encryption keys are good for financial industries where they need to scan what the container contains. They need to seal it, the container. I mean, I know what's the code itself, what binary is, what's the code itself, and I seal it so there is no tamper with it. It's actually a good feature for the financial industries and governments. Container health checks. This is late to the party. It has been added recently. You can add a probe. A probe is a special URL where the orchestrator checks if the container is still responding or if the container is ready. So you are able to actually set two types of probes. One is the startup probe. Let's imagine you have a backend which starts up very fast, but let's imagine you have a machine learning serving container, which needs 3 seconds to boot up because it needs to guess the artifacts, needs to guess the model, and it 2 seconds. the orchestrator can be instructed to have a ping of liveness of the startup check when you are ready for serving traffic. And this is a good thing to actually set you instantly to change revisions when you actually change new revisions of your deployments. Liveness probe is actually there to actually figure out if the container had a deadlock or it's, let's say, out of memory or different concept there could be. And if it's no longer responding in the decent time, that container is terminated. The good thing is that you can do this also on different channels, not just on HTTP. You can do also on TCP and gRPC probes. So it's actually great for a backend application and so on. It's a really good feature. You should try it out. Good. More recent additions. Session affinity. It's a concept when you have a client and multiple times it hits your containers. It's routed to the same containers. Service level objectives. This is an agile thing. So if you have a Scrum Master, it will know how to set your burn rate of producing errors or handling errors and budgeting errors. That's a thing as well for agile managers. Last one, and the good one, is that Cloud Run offers second generation environment, which means that you have access to disks. And that means that you are no longer a serverless thing because there is a persistence layer for the disk. But because the disk is there, it's a new heavy stuff, the cold start is higher. So you may have, you should expect a higher cold start as well. This opens the world to actually, we should arrive soon to serverless databases. Because that's the new concept. We have apps in serverless, but we need to pay full month a database. But the next concept is to actually have a database created in a way that they work nicely with networked storage and they behave in a serverless way for it. Final thoughts. I will skip this. This is much more easier. If we have different users accessing the service, like one in Oslo, one in New York, and we deploy the same app in the cloud to different regions like Europe North or US East, the balancer itself, because you can set up, it's not necessary, but you can set up a balancer in front of it. It will automatically route Oslo to the Europe region and so on. So this is out of the box for you. You just need to enable the balancer itself. Bonus. We always need a bonus to say it. Docker Slim. There is a utility on GitHub. It's called Docker Slim. Essentially, I already told you about many things that you can do to actually lower the cold starts, but there is Docker Slim, which is a minifier, and it can scan your code. Let me screen card. See people taking photos. So Docker Slim is a command line, provide a set of commands to build X-ray lint, and actually it will reduce the size and optimize your container. As a cold start, you will get 1-2%. It's not half, 1-2% only. But security-wise, the container is swiped, and it's keeping only what's necessary for you. And that means that there is the tampering to actually someone with your container is very, very reduced. So it makes much more secure because reduces the available attack surface. Essentially, I tried out for, I think this was a PHP app, like from 400, it reduced to 79. Why it's important? Because it can spawn containers much more faster because it's data. It doesn't need to actually wait on loading 2 gigabytes of information. I published an article about this. You can integrate into the cloud build. This is the commands. Actually, here you have the build phase, and you will have a secondary image with .slim. And you can deploy that. This needs to have a probe. So it doesn't fit on the screen, but there is a link where you access the website, where you access your service, because the probe will touch and do the stuff in the container, and what's touchable, it's kept in the container. What's not touched, it's not kept in the container. So, as I said, there is an article about integrating Docker Slim. Check it out. I'm not making Docker Slim, I just created the article. Conclusions. Enhance developer experience. So as I mentioned, different cloud vendors need different concepts for it. Google Cloud is a developer-friendly CLI, and developer, you don't need sysadmin. It can integrate with Cloud Code, Cloud Build for continuous deployment, so you can actually push to Git, GitHub Actions, enable you to automatically publish to Cloud Run, all this kind of stuff. It auto scales out of the box and scales down to 0, not just to 1. It offers you HTTPS, SSLs. It enables to use WebSockets, which is a new stuff, and you should try to use it to minimize the requests. And second generation environment, I talked you about this. Thank you for being here.